Okay, guys, get out your homework. It would be chapter 1-4, 1 through 32 all. Now, I'm going to bring up the answers for you. We ready? Okay. Number 1 is 23.2. Number 2 is -90. Number 3 is 12. Number 4 is k equals 1/2 r minus 15/2. Number 5, k is equal to 1/3 z plus 2. Number 6, k is equal to -1/6 h minus 7/3. Number 7, it was vocabulary. It said explain what it means to find a solution for the equation. Does anybody want to give me what they have written down? This is the part where you actually reply. What'd you get?
For number 7, I put only try to find the solution to an equation you find and solve for all the variables if there is any equation true.
Absolutely. You are finding the solution is going to be whenever you solve the equation, you're trying to find all the values that that variable can take on. That makes a true statement. The part of making a true statement is very, very important. Now, many of you probably just read that out of the back of the book because I understand you probably did. However, think a little bit outside the box. Understand that you've got to make the statement true. Okay. Number 8. Suppose you solve an equation and find that your school bus needs 4.3 buses for a class trip. Explain how to interpret the solution. Can you have 4.3 buses?
You can round it.
All right, if you have to put everybody on a bus, can you have 4 buses or 5 buses? It has to be a whole number. Which bus are you going to choose?
5 because you have more than enough for 4.
You have over 4 buses. Not enough for 4 buses, so you have to have 1 more bus.
But if you round it, it's still 4. But yeah.
If you would round it in the rounding estimation, it would be down to 4. But if you're trying to transport people, you have to go to someplace. You have to go up to 5. Okay. Number 9. I love these problems. Whenever you're trying to find errors, it's very, very important that you guys in Algebra 2 are getting used to checking your answers. Because what one student does consistently, mistake-wise, is not what another student does consistently, mistake-wise. One of you may have negative issues all the time. Another one of you may have distributing issues. Okay? So what is very important for you to do is to be able to check your work and figure out where your errors are. The only way you can do that is by constantly looking for errors in other people's problems. So number 9, what did they do wrong there? They did not subtract 10 from both sides. Does everybody see that? Okay? So looking for those errors are very, very important. How can you do that? Do the problem yourself, compare your work to their work. But you got to compare and then write in English, the actual language, what they did wrong. Okay?
But subtract 10.
I like that. That's English. Number 10 is 18. Number 11 is -81. Number 12 is 12. Number 13 is 14. Number 14 is 23. Number 15 is 8. Number 16 is 17/2. Number 17 is -5. Number 18 is 7/2. Number 19 is -1/9. Number 20 is 17/7. Number 21 is 3/2. 22 is 8. 23 is -6. 24 is 2. 25 is 0. Now 26, 27, and 28, I should have excluded those from that. I did not. I don't have time to go over them today because of all the lessons I want to get over for your homework. So I'm not going to take points away from you if you did not do them, but I will give you the answers if you did attempt them. Number 26 is 4 hours. 27 is 300 miles per hour, and then 600 miles per hour. 28, the width was 4.5 centimeters. The length was 7.5 centimeters. 29 was sometimes. 30 was never. 31 was sometimes. And 32 was always. Okay. How do we do? Okay. You have 2 options. I can go over them with you in class today, or we can get together and help each other. I can help you later. Would you rather that? Okay. All right, staple it, bin it for me, put it in the bin, I'll grade it later, and we're going to go ahead and go on to today's. If you would like to keep yours because you have to correct it, you're more than welcome. Stay on your notes, please. Okay, what are we doing today? We're still doing chapter 1-4 continued. Our game plan is solving for an indicated variable. If you have a highlighter, you need to get it out now. How many of you have one? How many of you need one? You're welcome. Like how I have my name on it? You got one? Okay.
We might pull this off.
I might hammer your head. Come on, no pulling off my fingers. I'll throw things at you. And it'll be most fun for me. All right. Do not snag the highlighters. Do not pull off the labels. I will throw things. Okay? Give them back to me at the end of the period. It is important, though, the way I'm teaching you today to do your homework, I'm giving you the highlighter for a specific reason, because it does help pull things out and clarify what you're doing. Today, we're solving for a specific given variable, but there's a whole bunch of them there. Okay? Here we go. This is number 33 out of your textbook. This is not your homework, but I'm using your textbook as examples so that you understand where they came up with them. And remember, any problem that I do in class for your notes is a possible test question, and any problem that you do for your homework is also a possible test question. So the fact that I'm doing your book work for you right now is a good thing for you to study on. Bam. Oh. Okay, this is 33. The directions say solve each formula for the indicated value. We are going to solve this for H. We're going to solve this for H. So I want you to immediately take your highlighter. And I'm going to do this the whole period too. What are we solving for? We're solving for H. Highlight what you're solving for. I know many of you might be annoyed and think this is useless, but as things get harder, you're going to be very thankful you have the highlighter. So what's attached to the H? The half and the B. Which one's uglier? The half. So let's deal with the half all by itself. So it's attached by multiplication, so how do I get rid of it? I divide, but when you divide by a fraction, what are you actually doing? Multiplying by the inverse, which would be the reciprocal. Excellent. So I'm going to multiply both sides by 2. Those cancel out, and on the left-hand side, I have 2a is equal to b times h. Notice I'm working from what direction? Left to right every time. Okay? Now, what am I solving for? Still solving for h. So what's attached? How is it attached? How do I get rid of it? So we're going to divide both sides by b. Now, do you see how I am writing this? Don't go making this one big long fraction with one small b. You do to one side what you do to the other side, the golden rule of algebra when dealing with equations, okay? From left to right, 2a divided by b is equal to, the b's cancel out, is equal to h. Done. Do we understand? This is a formula now for the height of a triangle, right? Given the area and its base. We have a formula now. Any questions on what I just did? Moving right along. 37. AX plus BX is equal to C. AX plus BX is equal to C. What are we solving for? In problems 37 through 40 in your text, it says to solve each equation for x. So we're solving for x here. So what do? I grab my highlighter, and I'm highlighting my x's. How many x's do I have? 2 of them. Okay, how many of you like to go fishing? When you go fishing, the cat's out, and what do you get out? You sit there and wait for 15 minutes. you're supposed to get a fish on the other end. That doesn't always happen, right? When you pull the fish out of the pond, right, you're pulling it out. What we are fishing for are what here? An X. So if I take an X and I pull out the X, I put the parentheses. If I pull an X out of this AX, what am I left with? I'm left with an X. If I pull an X out of this BX, what am I left with? A B. That is equal to C. What did I just do?
No, wait a minute. Why wouldn't that be 2x?
That's a good question. The question is, why would that not be 2x? Because whenever you pull something out, what does this look like here? If you were to have just this right here, what would you do?
It could be distributed.
You would distribute, right? Meaning the X is attached to the parenthesis by multiplication, which means if I distribute that in, I get the original problem, don't I? What we just did is we factored out what? What's that called? The letter starts with G, ends with an F, has a C in the middle. GCF, my golliness. GCF is the greatest common factor, right? It's the largest number or variables that two or more terms have in common. What we just did when we go fishing is we pull out what's in common between those two things. Now, in Algebra 2, factoring out the GCF is absolutely essential for all the things that we're going to be doing in the future. In the future, okay? Factoring out the GCF is essential. You will not be able to solve problems if you cannot do this procedure right here. So, if this is cloudy, still very murky like mud, can I go on to the next? Go back to my problem here. We good? Okay. Let's say you still can't see it. You can't see the factoring out. Well, I'm going to sidebar this over here. If I were to have a number in place of the A and the B, pretend there's a number. So I'm going to pretend that the A is a 2. And I'm going to pretend that the B is a 3. What would you do if you had 2x plus 3x? What would you add together? Those two numbers in front are called coefficients. Please, put that to memory. Okay? They're called coefficients. So the 2 plus the 3 is what you would add. And that would give you what? 5x. Now, we can't add the 2 and the 3 together in this case because they're also known as A and what? B. So isn't this right here, if you were to substitute and get rid of the 5x and put the A plus B times the x, isn't that the same thing as what I wrote up there? Are they the same? It's the distributive property on which side? The right-hand side that we typically do not like to see. Remember when we were doing properties? And I said, many of you have recognized the distributive property on the left-hand side, but you do not on the right-hand side. When you factor out a GCF, it's the same concept of what we just did over here with 2x plus the 3x. If your brain needs to pretend that those other variables are numbers, like pretend. I don't care. Okay? Now, what are we solving for? We're still solving for x, right? So I highlight what I'm solving for. What is attached to my x? The ugly monster, which is b plus c. So how do I get rid of that ugly monster? I'm going to divide by what is attached. So I get rid of the monster of a plus b. And which direction do I work from? We read in which direction? Left, right. So this cancels out. And I have x is equal to c over a plus b. Now, I'm being very picky and I'm talking about reading from left to right and working from left to right because I don't want you guys to start working on the right-hand side and then go back to the left-hand side and then go back to the right-hand side. I want you to go from left to right. If it's one side, you go to the next side, you don't look back. We all understand what I said? Moving right along, 38. For 38. What am I solving for here still? I'm solving for x because this is still the section of the text where it says solve for x. Okay? So I pull out my highlighter and what do? There's my x. Now, what am what is attached to my x? The a by division and the 5 by subtraction. Now remember, PEMDAS, please excuse my new Aunt Sally. When I introduced solving systems of equations, I said we talked about the present thing and we try to unwrap the gift without messing up the wrapping paper, and you do the first thing that they did last. So the first thing that we're going to do is what? Are we going to do the division, or are we going to do the subtraction? We're going to do that subtraction because that's the last thing that we did. So we have to get rid of that minus 5 first, correct? So how do I get rid of that minus 5? I am going to add 5 to both sides. So I have x divided by a is equal to b plus 5. Why can I not write 5b there? Because b is my banana and 5 is just 5. I don't know what 5 represents, but it's just 5. They are not like terms. Do we all get that? So I have to write it as b plus 5. Now, I'm solving for x, making sure I highlight, and what is attached to the x? And how's it attached? How do I get rid of the division? You multiply by the reciprocal. So I multiply the left-hand side by a, but hold up. How do I multiply the right-hand side by a?
The a plus 5. Did you just put the a with the b, the b plus 5?
But this looks really funny if I do that.
You just put a next to b.
You have to put the parentheses around it because it's not just one term that I'm multiplying by a. I'm multiplying the whole right-hand side by a, which means it requires parentheses because what are you going to do now? You're going to distribute. I work from left to right, the a's cancel out, I bring down my x, and then I distribute. A times b is ab. A times 5 is 5a. That puts me in my happy place, and I'm done. Now, if you leave it as x is equal to a times b plus 5, would I accept it? I would. Because did you solve for x? You did. You followed the instructions, which means I would accept either or. Any questions on what I just did there? Excellent. Moving right along. 39. I'm still solving for x here. So if I'm still solving for x, I pull out my highlighter. What in the world is this? Why does this look different? There's subtraction and division, but most importantly, I had subtraction and division on the last one, didn't I? It is connected, okay? It is connected. Now, here's what I want you to know. I'm going to highlight the whole top here. That is the head, the x is the head, the negative 2 is the body. And you walk around here in the halls with your head attached to your body. Can I separate them? That's some dead students going on there, right? There'll be no dead men walking around here. So we have to keep the x and the negative 2 attached together. Do not separate them. They stay as one unit. That's what we call a binomial. Do we all understand that? Okay? So what we're going to do is we're going to cheat a little bit here. And we're going to put that over 1. Do you remember whenever we solved multi-step equations at the very beginning of the year, what I told you to do when you have a fraction equaling a fraction, like we do here? Cross multiply is the correct answer. Absolutely. You want to make things simple. Remember what I said about deer seeds, all the different types that we have. There's many different ways that you can kill a deer. I don't care, the result is it's still dead. Same thing here. If you recognize that fraction is equal to a fraction, make life simple for yourself and simply cross multiply. And it becomes a little bit prettier. 1 times x minus 2 equals 2. And what do I do? Parenthesis m plus n. Does it look easier already? I don't have the ugliness of fractions, do I? What would be throwing you off now before I even solve for x? There's parentheses there. Wouldn't it be easier if I eliminated my parentheses by doing what? Distributing. So I'm going to distribute the 1, which does not change anything here. Do we all see that? Go to the next one. 2 times n is 2n. 2 times n is 2n. Now does it look nice and neat and normal? As if we all understand what normal is. What am I solving for? X. Get out that highlighter and ask yourself, what is attached to my x? How do I get rid of it?
Add.
So I add 2. I add 2. Why did I put the 2 clear to the right? Why is it going to go right there?
Because there's no,
Because the number 2 is not a like term to 2n or 2n. So I can work from left to right. The x comes down. The 2n comes down because it does not have a like term. The 2n comes down. And then also the 2. And you're done. Do we see it? Are we getting it? Keep on we go. Number 40. Two over 5 times the quantity x plus 1 is equal to g. Anybody have any thoughts? I'm solving for x still. I absolutely can put the x plus the 1 over 1 because then I can do what? Marry the tops, marry the bottoms. So I'm going to have 2 times the quantity x plus 1 all over 5 times 1, which is 5, is equal to g. What looks complicated right now? The top kind of looks ugly. So it's cosmetically challenged. So let's make it prettier. So what do? What property is that, y'all? It's the distributive property. So 2 times x is 2x. 2 times 1 is 2. Put it over 5 is equal to g. Give me the next trick. Talk to me. What am I solving for? What looks ugly? Look at my arms right now. They're in the shape of a treasure hunt map. And the treasure hunt map. An X, right? Cross multiply. If you cross multiply here, if you cross multiply here, we've got g over 1, right? 1 times 2x plus 2. 5 times g. Do I need to distribute the 1? No. I don't even need the 1 there. I'm simply showing you that step so that I don't lose anybody. So this gives me the 2x plus 2 is equal to 5g. And here's the question I have for you. What am I supposed to be solving for? What is attached to the x? The 2 by multiplication, and then the other 2 by adding. So order of operations says I do which one first? With a Christmas present. I get rid of the last thing that they did first. So the last thing that they did, PEMDAS, is what? Addition and subtraction. So I'm going to subtract the 2 from both sides. Working from left to right, I bring down the 2, and I have 5g minus 2. What am I solving for? X. So what's attached? 2, divide each term by 2, and you're going to get x is equal to 5 over 2g minus 1. Are we getting it, folks? Do you see what I'm seeing? Yes? Oh, let's have more fun, shall we? What do? I'm solving for x. I am solving for x. What looks ugly? Parentheses. The whole thing does look kind of cosmetically challenged. I absolutely agree. But not all of us can look beautiful every day. Sometimes we just got hit with the other stick. That's okay. What can I do to make it look a little bit better? Distribute. It will be easier. So if I distribute, I'm going to have C times X, which is CX, plus 2C, bring down the 5 is equal to distribute BX minus 3B. Okay. Do I have any like terms on the left-hand side? Nope. Do I have any like terms on the right-hand side? Nope. A like term means it has to have exactly the same variables with exactly the same exponents. Okay. So now, what am I solving for? I'm solving for C, correct? If I'm solving for, for X. If I'm solving for X, I highlight my X. Are we listening? Everything that has an X, it's kind of like the sorting game. When you sort laundry, you put the whites with one color, you put the darks with another color, the piles, right? Same thing here. It's the sorting game. I'm going to put all my X's on one side, and everything that does not have an X, I'm going to put it over to the other side. Okay? So where do you want to put what? It really doesn't matter. It's equally all ugly. So where do you want to put what? I want an X's on one side and everything else on the other. You want to add 5 to the other side? Why not? You got to start somewhere. So I have CX plus 2C is equal to BX minus 3B plus 5. What else do I got to do now? Get rid of the 2C. How do I do it? Subtract 2C from both sides. Left to right, CX is equal to BX minus 3B plus 5 minus 2C. Okay. Now what? Do I have everything that's an X on one side and everything else on the other? No. If you're not certain, get that highlighter back out. You're on opposite sides of the equal sign, right? If you're not certain, get that highlighter out. Now I need to bring what to where? That BX has a whole bunch of junk on the right-hand side attached to it. So I want to bring it over by itself to the left-hand side. So it's positive BX, so how do I get rid of that? Positive BX. Since it's a positive BX, I'm going to subtract BX from both sides. Okay? So now I have CX minus BX is equal to this junk. Negative 3B plus 5 minus 2C. Do I care about the junk on the right-hand side, really? I have to keep it there, but I really don't care about it. I really don't care about it whatsoever. Okay? I have to leave it there, but it's just junk. What am I solving for? Do I have all my X's on one side? Now, this is exactly what I talked about earlier. Remember fishing? We need to go fish, don't we? So what am I fishing out? I'm going to fish out an X. So if I have an X here, what? If I pull an X out of CX, what am I left with? Bring down the sign. If I pull an X out of BX, what am I left with? Bring the B down and just bring this junk down. It's just irrelevant. It's just junk. Now, what am I solving for? X, what's attached? How do I get rid of it? Divide by that. Make this all one big side. That's gone, and X is equal to negative 3B plus 5 minus 2C all over C minus B. And yes, it can be that nasty and massive. It's legal. Okay? Are we getting it? Excellent. Now, tonight for homework, what you guys have is this worksheet. This worksheet is not exactly an easy worksheet. You need to get that highlighter out while you're doing it. If you guys need to listen to the video as you're doing your homework so that you can hear those questions that I've been asking you the whole period, then I suggest you do it. You listen to music all the time. You can mute me. You can mute it, you can fast forward it, you can rewind it. You can pause it. Do whatever you have to do to get the homework done. Okay? Now, let's start it. We still got time. Nice try. I should do. Well, before we start it, can I do a couple more examples with you to make sure that you get all the hard ones from the book? Yeah. Write them in your notes still. Sorry about that, guys. Keep your notes out still. And we're going to do a couple of the harder ones still for your textbook, because the textbook is a little bit harder on these last ones than what this worksheet is. Okay? 56. We're solving for x. So what do you see there? I see parentheses that are kind of ugly and nasty. So what do? Distribute 3ATX minus 2AB. What did I do with my variables there? I put them in alphabetical order. Why would I do that? So that you can find your like terms easier. Distribute the C. C dx minus 2C. Do I have any like terms? Nope, it's all nasty. Where are my x's? My x's are on opposite sides, right? So everything that's not an x needs to go. Everything that is an x needs to stay with me on one of the sides. So I'm going to go ahead and deal with my x's first. And I'm going to subtract c dx from both sides. So I have 3ATX minus c dx, right? Bring down that minus 2AB. That cancels out the minus 2C. What am I solving for? I'm solving for x. Highlight that. Everything that doesn't have that in it needs to go away. So what needs to go away? The 2AB needs to go away. So how do I get rid of that? You're going to add 2AB to both sides. So I have 3ATX minus C dx is equal to negative 2C plus 2AB. What do I do? What do I do? Go fish, right? Pull out the X. That's their GCF. So if I'm going fishing, pull out that X. What do I get? 3AT minus CD, excellent, is equal to the jump. That's equal to the jump. And then I divide by what is attached to it, because I need to find x all by itself. So I'm going to divide both sides by that jump. And I have x is equal to negative 2c plus ab all over 3at minus cd. Are we getting it, folks? Digital or verbal response, please. Are we getting it? Okay. Do you see what I see? What are those? They're like terms. They have exactly the same variables, and they have exactly the same denominators, don't they? Can I bring them all over to one side? I can. So I'm going to subtract 3ax over 5 minus 3ax over 5. That's gone, and I'm left with negative 4c, because that's what's on the left-hand side. And now what is 1ax over 5 minus 3ax over 5? Negative 2ax over 5. Something equals a fraction. A number equals a fraction. What's the number over 1? And what can I do? Cross multiply, right? Right? You see that? 5 times negative 4 is equal to 1 times negative 2ax. Yes? Negative 20c is equal to negative 2ax. What am I solving for? Divide by negative 2a, and x is equal to negative or positive 20c over 2a, which is actually 10c over a. Now, do the worksheet tonight for homework. Try your best. Tomorrow we'll go over any questions you have in class. Have a great, great day, guys. Do not forget to return the highlighters so that we can have them for the next class. Have a great day, guys.